Hello students, I hope the screen is visible to you. So in today's session we will be seeing about complements of a set. Clear? And after this theory session we will be seeing some questions, some interesting and challenging problems related to the theory we have done so far. Okay? So let me start. Disclaimer. The images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Now we are going too deep into our session, starting with complement of a set. So we will be covering class 11th maths about De Morgan's complements and some related properties to complement. Clear? And then afterwards we will be seeing some challenging problems. So starting with complement of a set, very simple. If you are having a universal set U and a set A which is a subset of U, then the complement of A is the set of all elements of U which are not the elements of A. Simply. Here, if you recall the difference set definition, here you can interpret this complement of a set A in terms of difference also. So A complement is simply U minus A. Clear? So symbolically, we represent A prime, which denotes the complement of A. And the set builder form is collection of all elements from the universal set, and the elements must not belong to the set A. So you have to collect all those elements from the universal set which are not belongs to the set A. Clear? In terms of set difference, A complement is U minus A. Clear? Now, this small example related to the definition. If you are having your universal set with these 10 elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and A subset of U with 5 elements 1, 3, 5, 7, 9, then find out A complement. So please comment your answers. Very simple. You have to find out the A complement. So solution. Yes, indeed. We note that 2, 4, 6, 8, 10 are the only elements of U which do not belongs to set A. So A complement will be the set with these elements 2, 4, 6, 8, 10. Clear? I hope the solution is clear to you. Yes, you can define in a set builder form also. You can say you are collecting even natural number less than equal to 10 or strictly less than 11. You can say that. Clear? Now, another example. If you are having, if you are having U as your universal set of all the students of class 11th of a co-educational school and A be the set of all girls in the class 11th, then find out A complement. So please comment your answers. So solution. Since A is the set of all girls, then A complement will be a what set? The set of all boys from the class 11th. Clear? Straightforward answer. So if you have any doubt, you can let me know. Now, there is a note. If A is a subset of universal set U, then its complement A complement is also a subset of U. Clear? Straightforward? So, for example, if you are having a universal set with these 10 elements, first 10 natural numbers, A as your subset, so 1, 3, 5, 7, 9, then A complement will be your set with these 5 elements 2, 4, 6, 8, 10. Clear? So both A and A complement, both sets are the subsets for this universal set U. Hence, now an interesting thing is happening. A complement complement will be your set A itself. Simple. Clear? So A complement complement is nothing but collection of all X belongs to universal set and does not belongs to A complement. So you have to collect all the elements which belongs to the universal set but not belongs to the A complement set. So in this context, so you have to collect all those elements from the universal set which does not belongs to A complement set. So very simple. So you have to do what? U minus A complement. Meaning you have to eliminate all the elements from the universal set which belongs to A complement. So 2, 4, 6, 8, 10. So eliminate 2, 4, 6, 8, 10. You left with the elements 1, 3, 5, 7, 9 and the set represented by these elements is same as the set A itself. And this is not by some coincidence. Okay. So it is generally true that finding out A complement then complement will be your A itself. So it is clear from the definition of complement that for any subset of universal set U, we have A complement complement equals to A itself. Clear? Now another example. So here universal set with 6 elements 1, 2, 3, 4, 5, 6. A subset of U with 2 elements 2, 3. B subset of U with 3 elements 3, 4, 5. So you have to find A complement, B complement, A complement intersection B complement, A union B, and hence show that A union B whole complement is same as A complement intersection B complement. So try to answer this. Very simple. So first find out A complement. Very simple. A complement is simply you have to collect all the elements from the universal set which do not belongs to set A. So eliminate 2 and 3. You left with 1, 4, 5, 6. So A complement set will be this set 1, 4, 5, 6. Same goes for B. So you have to collect all the elements from the universal set which do not belongs to set B. So eliminate 3, 4, 5 from the universal set. So eliminate 3, 4, 5. You only left with these 3 elements and this set will be your B complement. Now, next A complement intersection B complement, meaning you have to collect common elements from these both sets. So you are having only 2 elements which are common to both 1 and 6. So A complement intersection B complement is simply 1, 6. Now what about A union B? So recall the definition for A union B is very simple. So you have to collect elements from set A as well as from set B and write down the repeated elements at once. So you are getting your set as 2, 3, 4, 5. So 2, 3 already written and 4, 5. 4, 5. Clear? Now A union B complement will be what? U minus A union B. Simple. U minus A union B. So complement is nothing but you can rewrite this in terms of differences also. And now recall the difference definition. So collect all the elements from the U set, universal set, and eliminate the common elements which also belongs to A union B. So eliminating 2, 3, 4, 5. So eliminate 2, 3, 4, 5. You only left with these two elements 1 and 6. So A union B whole complement will be 1, 6. And as we have concluded that A complement intersection B complement is your set with two elements 1, 6, and we have seen also that A union B whole complement is just set with two elements 1, 6, and both sets are equal. So A union B whole complement is same as A complement intersection B complement. Simple. Clear? So this previous example exhibits an interesting thing. What thing? So focusing on this, the complement of the union of two sets is the intersection of their complements, and the complement of the intersection of two sets is the union of their complements. So previous example shows what? This property or law, and this law we say De Morgan's law. So A union B whole complement is same as A complement intersection B complement. Similarly, A intersection B complement is simply A complement union B complement. Clear? Now, some related properties. So A union A complement is simply universal set itself. A intersection A complement is empty set. So this we can represent by a Venn diagram. So you are having your universal set U represented by this rectangle, and a subset A of U denoted by this green circle. Clear? And A complement denoted by this as you can see this whole pink shaded part. So this is your A complement. Clear? Now as you can see, if you union both the sets A complement as well as A, meaning if you shade green as well as this pink part using some red color, you will observe what? You will observe that the complete rectangle will be shaded. So complete rectangle represents your universal set. Clear? Now for A intersection A complement, meaning if you try to observe the common elements from set A complement and A, are you getting any common elements? No. So both sets A complement and A, both sets are disjoint sets. Or from this representation we can say that we do not have overlapping areas for A complement and for A. Clear? I hope this is clear from this representation. Now this De Morgan's law, simply using a Venn diagram. Clear? So A union B complement is equals to A complement intersection B complement. Here we are providing you Venn diagram proof. Clear? So try to see this left hand expression A union B whole complement. So you are having your universal set and two subsets of U, A and B, represented by these two circles A and B. A union B represents the area, the shaded area, this blue shaded area, which is covering both A and B parts. Clear? Now what you have to do is find out the complement, meaning you have to collect the elements which belongs to universal set but does not lie in this blue part area. So what you have to do is simply shade the remaining area. Clear? And the shaded area will be your required thing, which is A union B whole complement. Clear? I hope this A union B whole complement is clear to you, represented by this part. Now, for A complement intersection B complement. So first of all, what will be your A complement? So all the elements from the set U, universal set, which does not belongs to set A, meaning you have to shade your area outside the A circle. So we shaded the area outside the A circle. So this is your A complement. The B complement will be shade your area outside B circle. So this is your B complement. Now what you have to do is intersection, meaning find out the common area. So if you observe these two images, the common area will be what? Common area will be the same as represented here. Clear? This. I hope this is clear. The proof by Venn representation, Venn diagram. So simple. What we are doing is, first of all, we are observing this left hand expression A union B whole complement. So first finding out the A union B, recall the A union B, how we represented our A union B. So A union B is simply represented by the shaded part of both the circles, or the area covered by both the circles, which is here represented by blue. So A union B is this blue part. Now what you have to do is complement it, meaning you have to collect all the elements, or you can say that you have to cover the area which is apart from this area but inside the rectangle. So apart from this and inside the rectangle, you are getting this as your shaded region. Clear? And this is your A union B whole complement. I hope it is clear how both expression equals. Moving on to the second part of the De Morgan's law, which says A intersection B whole complement is same as A complement union B complement. Now the approach is same. So first observe A intersection B. So A intersection B is simple. You have to shade the overlapping or the common part, which represents your elements which belongs to both the sets. So this green part will be your A intersection B. So far so good. Now what about its complement? Simple. Complement meaning you have to shade area outside or apart from this shaded area but inside the rectangle. So apart from this shaded part, you have to shade. Clear? And we are getting this as our new shaded part. And this shaded green shaded part is represented by, in terms of intersection and complement, as A intersection B whole complement. Meaning we are collecting all those elements in universal set which does not belongs to the intersection. So as you can see, we do not include the intersection elements here. Clear? It is all coming from the definition. Now let's observe these A intersection union B complement. Sorry, A complement union B complement. Now first of all, what is A complement? Simply area outside the circle A. Meaning this gives me, we are collecting all the elements from the set U but which does not belongs to the set A. And we know elements belongs to the set A are inside the circle A. So we are not shading this circle A. Clear? The same goes for B complement. So B complement is simply represented by the shaded part outside the circle B. Meaning we are collecting all the elements inside the set U but not in B. So as you can see, we are not collecting elements from B inside B. Clear? Now what you are doing is union, meaning you are taking shaded parts. So union says what? You have to collect all the elements which belongs to A complement or belongs to B complement. We know these all elements represented here shaded all belongs to A complement, and these shaded elements here all belongs to B complement. So the total shaded region will be this, represented by this fifth diagram. Clear? And this is your what? A complement union B complement. And if you try to see, both second and this fifth diagram are the same. So we say that A intersection B complement is same as A complement union B complement. I hope these two laws of De Morgan are clear to you. Very important. Now, as we saw from an example that A complement is A complement, then whole complement is A itself. Yes, in terms of, you can say that we are avoiding that part. Clear? A complement, complement of some set gives you avoiding the elements from that set. But keep in mind that we are still taking elements from universal set. Do not go beyond the universal set. Clear? Always keep your head on the universal set. So this is your law of double complement. So A complement, then again complement will be your A set itself. Now fourth is simple, law of empty set, which says that complement of empty set is universal set itself. Yes, meaning in terms of difference, if you recall, this will be your what? U minus phi. Meaning you are collecting sets from the universal set and eliminating all the elements which belongs to this set. Here we do not have any element in phi set, so you will get U itself. So phi complement is U. Clear? Now U complement is very simple, U minus U. You know, so U minus U meaning empty set. You will be getting empty set by definition. Clear? I hope this is straightforward using the definition. So for this theory part, this is it. Just wait for a second. We will be seeing some problems. So is it visible to all? So please comment. So we are going to discuss some problems, some challenging problems. Clear? So please participate. So in NEET we do not have mathematics. Yes. So starting with this, clear? Solve with me. So simple question you are having, and here we are going to see problems only related to the theory we have discussed so far. Okay. So this question says, in a class of 60, first of all, this question is related to Venn diagram. If you can see, in a class of 60, clear? In a class of 60, 25 students play cricket, 20 students play tennis, and 10 students play both the games. Then the number of students who play neither. So comment your answers. So some of you saying 25 is okay. So I'll be taking the option. So So 25. Okay. Okay. Next. So here we are just, so let me, okay. So just wait. So yes, indeed 25 is your correct answer. Very simple. I hope all of you are getting 25 as your answer. Yes. Okay. Very simple. Let me just wait. Okay. Now just see that we are having total 60 students. Yes. Total 60 students. Simple. Total students who plays the both games 10. Yes. Total students who plays only cricket 25 minus 10. So here the students who plays only, so we are using only word here, so only cricket, meaning 25 minus 10. In total we are having 15 such students who plays only cricket, and students who plays only tennis 20 minus 10 meaning 10. And total students who play neither tennis nor cricket is very simple. So we are subtracting from the total, that we are having total students 60. So 60 minus students who plays only cricket, student who plays only tennis, and student who plays both. So eliminating all these students, we only left with the students those who neither plays cricket nor tennis. So we are having only 25 such students. Clear? So is it clear or not? Shall I move to next? Comment? Okay. So moving on to next. Simple. So 8th. Simple. So very straightforward question. Simple, easy. So here in question, the set of intelligent students in a class is. The options are: is it your null set? Is it your singleton set? Is it a finite set, or not a well-defined collection? So please comment your answers. So mostly students giving me the D option is the correct option. Indeed, D is the correct. Why? Why? Because you are not able to decide what elements or what students will be in this set. When you are having such condition, when you are not able to decide, this gives you not well defined condition. So not a well defined collection. Clear? I hope the explanation is clear to you. Very simple. You can attempt the whole DPP or the whole chapter wise, topic wise test from the Sathee website. Okay, here we are just doing from selected problems, as we only covered some of the theory. Clear? It can be, but first of all, it has to be well defined. It totally depends on the how we are defining our set. Clear? So here in this context, it is not well defined. It is not forming a set. Clear? So shall we move to next? Comment. You can attempt the complete test on the Sathee website. Again, I am repeating that. So moving on to next. This simple question. So many of you are seeing the correct answers, but the main is how you are getting to the answer. or so please share your approach. The main thing is how you are getting to the answer. So set A in set builder form is given to you, collection of all x. So just wait. So collection of all x such that x is from set of reals. X square, so you have to collect all real numbers following these two equations, meaning x square is 16 and 2x is 6. So answers, comment your answers. Are we getting empty set or set with 3 elements 14, 3, 4 or singleton sets 3 or 4? Simple question. The approach is very simple. You have to solve for these two given equation first of all. So if you solve for this, you will get x is equals to plus minus 4, and from here you are getting x as 3. Yes? And you are not getting any x which satisfy both of the equations. We want both of the equations to be satisfied. Here we are using the word and. Please see that. Please observe carefully. So here we are using this word and this represents that you have to see for the element or a real number which satisfy both of the equations. Both of the equations. Clear? So in this context, your set will be empty. Okay? And if we used or, yes, if we used the word or, meaning we have to see for such real numbers which either satisfies the x square is equals to 16 or satisfy 2x is equals to 6, then the set will be indeed 4 minus 4 and 3. Clear? So it totally depends on this word and or. I hope it is clear now. Clear? So suppose if someone says that x belongs to set of naturals and use the word and, then the set will be still empty. But if you are using or and use x belongs to n, then the set will be with two elements 4 and 3. Clear? These are just some minor changes to the conditions. Clear? So shall we move to next? I hope this is clear. Okay. Now this, let me clear this. So answer this. In theory, I have already told you the number of total subsets from any set containing some definite elements. Just a direct answer. Here I'll be providing you a proof, not a proof. We haven't done the combination and permutations yet. So still I'll be providing you with the proof. Okay. Yes, PNC, we can use that. So okay, we are going to skip here the proof. Okay, or you want the proof using PNC? Okay, simple. If you recall, not recall exactly. So let me just clear something for you. So the correct answer is obviously 2 raised to power n. Simple. Clear? Now, so in the proof of this, we require some basic knowledge in PNC combination, especially in combination NCR. So NCR represents your from out of n objects and distinct objects, you have to select R. Clear? So let me take an example. So starting with say you are having your set with 3 elements. Okay, now set with 3 elements. From this gives you number of total subsets 2 raised to power 3, meaning 8. Now how we are getting these 8s? Very simple. So first of all, phi is your obvious subset. Clear? And in this set we are having no element. So what we are doing is we are choosing none. We are choosing no element out of these given 3. So here we are going to use this NCR form, meaning out of n we are choosing R. So out of 3 we are choosing 0, which gives me sets with no elements. So sets with no elements by formula, it is nothing but n factorial by r factorial and n minus r factorial. Clear? So this you have to assume it as a fact here. Okay, it will be all clear how we got this expression in PNC. Clear? So this 3C0 gives you set with no elements. Set with no elements. Clear? Now here if you solve using this, you will get what? Answer. So solve it. What you will get? Simple 1, and this represents your phi set. Clear? Now you are going to select one element out of these 3. So how many elements you can select? In how many ways? Simple, 3 ways. Clear? And what are those? Very simple. So you can choose 1, you can choose 2, and you can choose 3. So you are having just 3, and these are the subset for this set A with only 1 elements in it. So you are having 3 subsets having exactly 1 element. Clear? Now what this represents is choosing 2 elements out of 3, meaning we are constructing a set, a subset of A in which we are having exactly 2 elements. So exactly 2 elements, 1 2, 1 3 and 2 3. Clear? And this evidence backs up this expression 3C2, meaning if you solve using this formula, you will get what? 3C2 is simply 3. So again you are getting 3 subsets in which you are having exactly 2 elements. Now you are constructing subset of A which consists exactly 3 elements. So exactly 3. So number of ways, only 1. So you are going to have only one subset of A in which you are going to have exactly 3 elements. So the set will be your A set itself. Clear? And this will be true for any set with having elements n. So what we are doing is just constructing the subset as NC0, NC1, NC2 till NCn, which gives me, this is a direct from binomial, that this is your 2 raised to power n. So here we use this as our fact, this as our fact. Okay, so don't worry, it will be all clear when we reach to PNC. So for now, just see these as facts. Clear? So shall we move to next? We are only left with some limited time. So we are having only 10 to 15 minutes. Okay? So Shall we move to next? So moving to next. So 12. I think 13. So try this problem. Two sets in set builder form are given to you. Very simple. Try to write down their roster forms and try to see, are we getting both sets equal? Are we getting B as a subset of A or A as a subset of B or this B option? Clear? So please try. Very simple. Just try to write down the first 4 to 5 elements. That's it. I think 4 would be enough. Just write first 4 elements to both the sets. You will get the idea which one is superset and which one is subset. So for set A, write down the first 4 elements, please. So you can use n 1, 2, 3, 4. And the same goes for set B. You can use n 1, 2, 3, 4 as we are taking n from the set of naturals. Okay. So hurry up. It's very simple task. So for A, so just n1. So if you put n1, this will be 6 minus 5 minus 1, which is 0. So 0. 0. Now for n1, again 0. For n2, this will be 50. Yes. For n2, this will be, 25. Not 50, 25. For n3, this will be 50. Okay. Now, for n1, we have seen we are getting 0. For n2, 36 minus 10 minus 1, meaning 36 minus 11, meaning 25. And next will be what? Very simple. Just evaluate. So 36 times 6 minus 15 minus 1. Yes. For using n as 3. So 36 times 6 minus, as we are using n as 3, so very simple. So 15 minus 1. So tell me, what is it? So simple, 216 minus 16 will be 200. So next element will be 200. Now for this, we are having a 50, and next element or the fourth element will be what? So we have used 1, 2, 3 and 4. If you use 4, you are getting 75 and so on. Okay. Now try to observe that all the elements 0, 25 or from this set A, we are having that these elements also belongs to set B. So this satisfies the definition for subset. Clear? A is your subset for B. I hope it is clear. So C option will be your correct option. Anybody facing any problem? So let me know. So direct approach for this is very simple, that we are going to write some of the elements and try to see that in which set we are having extra elements, and that set will be our superset. The approach is same, just writing out few elements. So let me repeat, for set A, we are getting some of the elements as 0, 25, 200 and so on. Yes. Is it clear for set A? So for n1, we got 0. For n2, we got 25. And for n3, we got 200. Clear? Now, for B set, for n1, you are getting 0. For n2, what you are getting is 25. For n3, you are getting 75. Yes, and so on. So it is quite clear that what we are having here is multiples of 25. Yes, multiples of 25 including 0. So 25 times 1, 25 times, so next will be 50, sorry, 50, 75, 20 times 2, 20 times 3 and so on. Here we are having elements of this form, and this is also your multiples of, not all multiples but selected multiples of 25. Clear? So here we are having selected multiples of 25. Here we are having all multiples including, also here we are having an extra element as 0. So all multiples union 0. So extra elements, meaning this B set will be our superset. I hope it is clear. One can also think this 6. So this will be, so you can write this as some 25 times integer. Why I am saying that? Very simple. That here, so this can be done by using binomials. Okay, so I am just giving you another approach. That's it. So we do not have seen binomial yet. Clear? So different approach, just for curiosity, that 1 plus 5 raised to power n is simply what, your 6 raised to power n, and this is nothing but nc0, nc1 plus nc2 5 square and so on. Yes, and this is nothing but, if you try to see, if you try to solve, this is your 1, this is your 5n, so 5n which is equals to plus nc 3 5q and so on till some finite term. So what we are doing is very simple. So we transfer these two elements to the left hand side and take out 5 squared from each element. So we are getting like this, nc3 5 and so on. So as you can see, this expression is already given to you, and you can see that this expression is some multiples of 25. Clear? So this is some extra approach, so you do not have to worry. Here in context, what you have studied so far is just try to find out some of the few first elements. Clear? And you will get your answer. So shall we move to next? And that question will be our last. Okay, so moving to the final question. So please do attempt all the questions from this set or today's DPP. If you find any difficulty, let me know. Let me know what you are facing with. Okay, I'll help. And here in live sessions, we do not have much time. So please join doubt clearing session on Zoom. There we will explain all the doubts, all the answers to you. Okay. So answer this. So 14, the difference set between the number of subsets of set A and B given to us as 120. So total number of subset of A minus total number of subset of B, हमें कितने, we are given with 120. Okay, clear? So you have to choose the incorrect option. Very straightforward. We have seen a problem related to such questions, if you recall. So first, let me give you an approach. So first assume total number of subset of A as 2 raised to power something, and then for B 2 raised to power another something. So please do answer. I have given you a hint. Very simple. So straightforward. Suppose number of element in set A n and number of element in set B m. So total number of subset for set A is going to be 2 raised power n and for set B going to be 2 raised power m. Clear? Yes, option C is the correct. It is not correct actually, but in this context the correct option is C. Now, so total number of sets 2 raised power n for A, total number of subsets for B 2 raised power m. Yes, yes, option C is correct. You are saying the correct option. Now, the difference is already given to us. So, we are given with this much of information. As we are having 2 raised power n minus 2 raised power m something positive. Yes, so this gives me that n must be greater than m. And n and m both some integers, positive, natural number. So, we can take 2 raised power m common. So, 2 raised power n minus m minus 1. Yes, now factor this. I hope now you are start recalling that we have already seen a problem on this similar pattern. So here focusing on this. So this is your what? Simple, you can factorize it, very simple. So 12 times 10, this gives you 2 square times 3 times 2 times 5, which is 2 raised power 3 times 15. Yes, and now you can compare that you are getting m value as 3. Yes, you are getting m value as 3, and now this 15 can be broken down into this form. How? 2 raised power something minus 1. Can you find out nearby number which is of the form 2 raised power n? Yes, 16 is 2 raised power 4. So this can be rewritten as 2 raised to the power 4 minus 1. Yes, clear? So 2 raised power 4 minus 1 is 50. So very simple how we are writing down this, or how we took the 2 raised power m common, very simple. So please try to see or observe from this equation that is this clear or not. First of all, is this equation clear or not? How we are getting? Okay, now you know 2 raised to power n. So first of all, n is what? Some natural number, agree or not? So n, both n and m belongs to some natural numbers or not? Yes? Okay. Now, as both belongs to some natural numbers and we are having that 2 raised power some natural number minus 2 raised power some natural number is equals to some 120. Yes, and this 120 is some positive number. So what I am concluding from this equation is that this difference is positive. Agreeing? Meaning 2 raised power n minus 2 raised to power m is positive, which gives me 2 raised power n is strictly greater than 2 raised to the power m, meaning n must be greater than m. Agree? I hope it is clear. Okay, now if n is greater than m, say let's take an example. So if you are having any doubt, please specify it, then I'll be only able to answer it. So n is strictly greater than m. Yes, say in this case you can write 6 is greater than 4. Suppose I am taking an example, that's it. So I can write this 6 and this 4 in a relation as 6 is equals to 4 plus some other natural number. Clear? Okay. most of you are not getting what I am talking about. Okay, let me clear this board. So now, so is this step clear or not? First of all, is this step clear or not? Please comment. Okay, is this clear or not? 2 raised power n is strictly greater than 2 raised power m. Is this clear? Okay, this is also clear. Okay, now I am concluding from this that n must be greater than m. Is this clear? Okay, this is also clear. Okay, someone saying no, not clear. So, okay, let me again clear it. So, we are having 2 raised power n is strictly greater than 2 raised power n. Very simple. That suppose n is smaller than m. Suppose n is smaller than m. Okay, meaning, for example, let's take an example. So say 6 is smaller than 7. Yes, 6 is smaller than 7. Then can we have the condition where here what we have used is simply n is 6, m is this. Can we have 2 raised power n greater than 2 raised power m? No, because 2 raised power 6 is not greater than 2 raised power 7. Clear? I hope from this example it is clear. In order to have this, I must require n greater than m, as both n and m belongs to natural numbers. This is only true when you are having this thing. Is it clear or not clear? So as we do not have much time, so let me just quickly solve this for other students. Okay, and those of you who are not getting the solutions, please join the Zoom doubt clearing session. We can clear all the doubts there. Okay, so sorry for that. Let me solve further. So now what we did is took 2 raised power m common. So n minus m minus 1 is equals to 2 cube. What we got is 2 cube minus something like this. So m is, by comparing, m is 3, n minus m is 4, which is n is 7. So we are getting m3 and 7, meaning number of element in set A 7, number of element in set B 3. Clear? Now, as we are having number of elements in A 7, let me just clear the board. So what we have so far is number of element 7 and number of element in B just 3. Yes? Clear? Now, in best case, the intersection will be common elements. So maximum value in the intersection will be the 3. So this is correct, but we have to find out incorrect one. So this is true. Now, minimum value of intersection B. Yes, we can have the situation where A and B both sets are disjoint. Yes, so this is also true. Might be possible case. For last, maximum value of n A union B. So A union B, minimum value of A union B, minimum value, very simple, minimum value. Suppose when B is your subset of A, meaning in Venn diagram you can represent B A like this. Yes, then A union B will be your set A itself, then A union B will be A, and in A you are having 7, so you will get 7. So this might be a possible case, but this won't be. Why? Because n union B, suppose if you are having two distinct sets, the best case is to have two distinct sets A and B, meaning no common elements. Now A union B will have how many elements? The total element from this and total element from this. So you will have total 10 elements. Yes, I hope this is clear. So there is no case when you are getting the number of element in the union set as 21. So incorrect. So option C will be your incorrect. I hope this is clear. Those of you who are not getting the correct answer or not satisfied the solution, please you can join the Zoom doubt session. That will be very beneficial for you. Okay. So thank you for this amazing session and thank you for your participation. So you attended this class carefully. So thank you.